There are two people already.
Yes, sir.
Participants, if you have any questions, please go ahead. Kuldeep, Sanchita ji, you can
Yes,
ask
sir.
questions. Yeah, you can. If you have any clarification doubts, please let us know. Hello.
Hello,
Any doubts?
sir. I have a doubt कि
Ask me, please. Huh?
जब हम स्पेक्ट्रा देखते हैं कॉसी एंड टॉक्सी का,
Okay.
तो हमें इन दोनों के स्पेक्ट्रम में थोड़ा डाउट रहता है कि कॉसी का आई अंडरस्टैंड बट टॉक्सी आई हैव क्लैरिटी तो थोड़ी कम है इसमें.
Okay. So I don't understand Hindi, but if you can tell me in English, it is better. See, last year
I
my
have low clarity in टॉक्सी.
Toxi. Okay. But you know what is COSI, right?
Yes, sir.
Okay. Let me explain to you. COSI is an two-dimensional experiment where it will establish correlation between the coupled partners, coupled spins. For example, in a molecule CH3, CH2, CH something is there, let us say. CH3 is coupled to CH2, CH2 is coupled to CH3 like that. COSI gives a cross peak between two spins which are coupled to each other. You understand?
Yes, sir.
Whereas in the case of Toxi, what happens? Consider a situation. There are four different types of protons. A, B, C, and D. Four different protons. A is coupled to B, B is coupled to C, and C is coupled to D. All four are coupled to each other. In Toxi, you have to go step by step. You'll see the coupling between A and B, and then from B, you go further, and you get the coupling between B and C, and then from C and D, like that. You have to go step by step. So you keep getting the cross peak. First between A and B, sit on a diagonal of A, go horizontal, vertical, and complete the square. That shows A and B are coupled. Again from B you have to go, and then you complete the square, you will get C. Again from C you can go on D. So in COSI, you will go in different steps. In fact, 3 or 4 steps you have to do. But in the case of Toxi, what it means is all the spins A, B, and C are coupled among each other. Okay, among themselves they are coupled. A is coupled to B, B is coupled to C, and C is coupled to D. So in the case of Toxi, you will get cross peak, not one, for all the four at a time. For example, A, B, C, D are the cross diagonal peaks. You get cross peaks for all four, A to B, B to C, C to D, everything you are going to get. So you from one diagonal, go horizontally, you will find out how many peaks are there. And if you go vertically also. What it means is, in the case of this thing, Toxi, in one experiment, you can identify all the coupled partners. You don't have to go step by step. That is the advantage. So Toxi identifies coupled partners. I'll show you in one of the slides here. Please be on the line. I'll show you now. Okay, I am going to show you one slide. You please see it carefully. Are you able to see this?
Yes,
Sanchita,
sir.
are
Yes,
you able
sir.
to see now?
Yes, sir. See.
Okay. Okay, now what I'm going to explain, you understand? This is a molecule where we have O in between. One is coupled to two, two is coupled to one. That's okay. But between there is a, between two and three, there is a O here. There is no coupling between two and three. Understand? You are silent. Hello, Sanchita.
Yes, sir. Understand.
You have to say yes or no when I'm talking.
Okay,
3
sir.
is coupled to 4, 4 is coupled to 5, 5 is coupled to 6. What did I tell you? All these 4 protons which are coupled, they form one group called spin system. Similarly, 1 and 2 are coupled. It forms one spin system. And there is no coupling between 2 and 3. So that means these two are isolated spin systems. Two spin systems are different. What Toxi does is, it will identify all the spin systems in one experiment. Look at it. I have a peak here. I will consider this as CA3. I don't know which CA3. I will start with this. Okay, I'll start with this CA3. This will come here. I don't know why this is coming in the way. I will say. Okay. So now we are going to see. Can you see this one? I'm going to
Yes, sir.
sit on this diagonal here. Okay. Sit on this diagonal here. Draw a line horizontally. I'm sorry, vertically. Draw another line. I complete the square. Okay. From this diagonal, can come down, go horizontally, go vertically, go again, come horizontally. You will complete the square. Same thing you will also get in COSI like this. That means this proton and this proton are coupled to each other. Are you okay with me? That is possible. In this molecule, only 1 and 2 are coupled. And there is no other coupling for this thing because there's a breakage in the coupling here. Molecule, there's a break here. On the other hand, we start with the other one. Look at this one. I start from this diagonal, come down. See, it is not hitting one peak, it is hitting 4 peaks. See here, there are 4 peaks. 1, 2, 3, and 4. This diagonal, there are 3 cross peaks. It hit all the 3 cross peaks. Now, what is this peak? This is CA3. This is CA3.
Hello.
So this CA3 is coupled to this.
Hello. Sir,
So
your voice is breaking.
my voice is breaking. Okay. I see now. Can you understand this one? This is 6. 6 is coupled to 5. 5 is coupled
Sir,
to
I
4.
don't able to clear hearing because voice is breaking.
I on my video, I'll stop it. Then it will be better. Okay. Now you can try. Are you able to hear now? Now you can see. Can you hear me? Now I have removed my video so that bandwidth is
Yes,
better.
sir. Yes, sir. Now clear voice
Okay.
is coming.
So yes, better. Now I'm going to sit on this diagonal and try a vertical line. It is hitting 3 cross page. 1, 2, and 3. I know this is a 3. This one. So it is coupled to 5, 4, and 3. All the 3. So it identify all the coupled partners in one shot. Just by one vertical line or horizontal line, if you draw a line like this, all the cross peaks will tell you all 3 cross peaks and this diagonal together.
Sure.
They form what is called a one spin system. They are called coupled partners. This is what Toxi identifies. You understand? If you have to do in COSI, start with this, come here, and from this diagonal come down, come here, and like this. You have to go like a ladder in the case of COSI. But in Toxi, one experiment, if you draw a cross peak like this, one vertical line and a horizontal line like this, you will identify all the coupled spin systems. You understood now? That is the difference between COSI and Toxi. Are you okay?
Okay, sir. Okay, sir.
Okay.
Good morning, sir.
Good morning. Yeah, tell me, please.
Sir, when we apply the B1, the induced applied external field is very necessary to make the transition between spin state. That angle is always 90 degrees. Suppose Bx, By, and Bz. Why this is always perpendicular to the static magnetic field, sir?
Correct. That is a very good question. The problem is the RF power what you are going to apply, you can treat it like another magnet. Because it is like RF means you are applying an electromagnetic wave. It has a magnetic component, electric component. We are dealing with a magnetic component. If you apply in the same direction along the magnetic field, along Z direction, you are adding to the main magnetic field. That doesn't help. You have to perturb the spins, perturb the spin system. That means it can happen only when you can apply in the direction perpendicular to the Z magnetic field. That is along X-axis or Y-axis. Otherwise, the magnetization is not going to be perturbed. If you apply along the same Z-axis, it is like adding 2 magnets. Magnetic field strength will be added up. It will not disturb the spin system. So perturbation of the spins or magnetization is essential to detect the signal. That is why we are going to apply the RF field in a direction perpendicular to the magnetic field. You got the point?
Yes, sir. Okay. Good.
Okay. Any other question?
Sir, one question is that the time scale of the electron spin is 10 raised to the power minus 4 to 10 raised to the power minus 6. In the case of NMR, the scale is minus 1 to 10 raised to the power minus 9. When we are capturing the proton, this electron is not coupling. Coupling between electron is not affecting the spectra of the proton. The time scale.
Your voice is breaking. Can you repeat it? Your voice is you switch off your video. Maybe then you can repeat again.
Sir, just a minute. Sir, I am audible, sir?
Yeah, now you are audible. Yeah.
Sir, I am asking the time scale of the electron spin is 10 raised to the power minus 4 to minus 8. And the time scale of the NMR is 10 raised to the power minus 1 to 10 raised to the power 9. When we are taking the NMR, suppose proton, carbon, or nitrogen signal, is there any effect between the electron coupling and the nucleus coupling or nucleus or electron coupling. Same
See,
phenomenon.
electron nucleus coupling is not there. It is only the coupling between two nuclear spins. See, if you want to disturb electron, you have to do it at a different frequency, not radio frequency, that you have to do in the microwave region. That is what is called electron paramagnetic resonance, EPR or ESR. Whereas you are detecting the nuclear spins, that is in the radio frequency region. It is nothing to do with interaction with electrons. But electron has a role in this
Yes, sir.
sense because they are circulating electrons, generate the magnetic field. As a consequence, there is a chemical shift. It is the field at the side of the nucleus is affected. Also, in a ferromagnetic material like our paramagnetic materials, where there are unpaired electrons, it affects the nuclear spin. It relaxes faster. So there is an indirect effect there, but there is no direct coupling between electron and nuclear spin.
Okay.
You understand?
Yes, sir.
Yes, please. Any other question? Anybody else?
Uh, we if there is some molecule, let's say the peptide molecule,
Okay.
we directly go to 2D NMR or selectively, or we have to do one NMR, proton NMR essentially
See, it
directly.
depends upon the size of the molecule. If you have a peptide, if this dipeptide, let's say 2 amino acids, very simple spectrum, you can do one by
Yes,
1D. You can do by 1D. If you go to a bigger molecule, like a tetrapeptide, decapeptide, or even 20 or 30 amino acids are there, then it is going to be a big molecule. And each
yes,
amino acid, you can see it has got protons, right from CH3 group, C alpha, C beta, etc., up to NH proton. It
okay,
forms an amino acid. You know, that is
okay,
amino acid, you have right from CH3 group to NH proton. There are so many protons are there in each molecule. Each of them give rise to a lot of peaks. Like that, if you have a lot of amino acids joined together in the primary
okay,
structure of peptides or proteins, it is nothing but the sequence of amino acids. If there are
yeah,
more
yes,
number of amino acids, each amino acid has lot of protons and lot of peaks coming. Not only chemical shift because of J coupling interactions. The spectrum will be very, very crowded. In such situations, you can go for 2D. You
okay,
understand? 1D is
yes, sir.
just sufficient for a simple molecule. You have to decide
Okay,
based on the size of the molecule and how complex the spectrum you are going to see. Even in small
okay,
molecules, sometimes the spectrum can be complex. But a lot of peaks will be there, overlap will be there. In which case, you can go and do 2D experiments. Basically, for small molecules, you don't need 2D. 1D is just sufficient. You understand?
yes, sir. I got it.
Very good. So anybody else? Any
Sir,
other question?
one more question.
Yeah.
Suppose the less abundant discipline like 15 nitrogen,
Hmm.
so less, how we are enriching, because we have to enriching the sample. How we can do it, sir? Enriching
This
process.
is the question you are asking for a wrong person. It is only chemists can do. I am not a chemist. I don't know. The
Sir,
chemists generally
I
they
never
do.
did it. That's why I asked you, sir. I never did it. That's
And this is
why
only chemistry people know how to do what is called isotopic labeling. That I don't know.
okay,
It is chemistry part. So you have to ask
okay,
some
okay.
chemistry people who are in your group, in
Okay,
your
I will
department.
ask. Because I never
They,
did it. That's why I asked you, sir.
yeah, this is
Uh,
isotopic. It is a simple chemistry. In the
okay,
laboratory, in
okay,
the
okay.
chemical laboratory, they will do it. How do they do? I don't know. That you have to ask some very good chemist. It is a
Okay, okay.
simple reaction where one isotopomer, for example, carbon 12 is there, carbon 13 is there. They will make
Okay.
sure that all carbons are carbon 13. That is called labeling, isotopic labeling or enrichment. There is a way to do that you have to ask
Okay.
chemist. One thing I can
Okay.
tell you, you are already getting, let us say, labeled molecules are available. For example, glucose, carbon 13 labeled glucose you are going to get. Generally, for biomolecules, let us say if you want to feed for bacteria or anything, you have to feed this instead of ordinary glucose, you have to feed the enriched glucose for the animals or the whatever the biomolecule which you are trying to do. And then automatically you are going to get a molecule which is labeled. That is another way of doing. But in a chemistry way, in the laboratory people do. You have to go and ask some chemists.
Okay, I got it.
Anybody else? There is a new person, Vishnu. Vishnu, do you have any doubts?
Sir.
Yeah.
Good morning, sir.
Good morning. You have any clarification doubts?
So can we see nanoparticles monitoring on the NMR, sir?
Why not? Depends upon which type of nanoparticle you are looking at. People are already working on some nanoparticles also. Nanomaterials, nanotubes, that also people are trying to do. But depends which type of nanotube. For example, carbon nanotubes, you can look for carbon 13
Carbon
NMR.
counts.
You can do carbon 13 NMR and see that if it is a carbon nanotube.
Thank you, sir.
If a particular nucleus is there, if it is detectable, if it is the NMR active spin, you can do it. Depending upon whether it is a solid state or solution state, accordingly, you have to do the experiment.
Oh, okay, sir.
Anybody else? Sanchita, you have any other questions?
Sir, hello.
Tell me.
Sir, I have a doubt about correlation time because one question asked in assignment 8, I am not able to do this question because there is asking correlation time, but I share the picture of that question.
Correlation time means the time required for the molecule to undergo rotation by 1 radian, the time required. That is the definition of a correlation time. You got it?
Okay,
Sanchita,
sir. Yes, sir.
you have to speak loudly.
Yes, sir.
See, what is the meaning of correlation time? If there is a molecule which can undergo rotation, the time which required for the molecule to undergo rotation by 1 radian is called a correlation time, which is called tau c.
Yes, sir. But in nanosecond तो पूछा गया था उसमें जो हम नहीं कर पाए हमें I can't done this question because I can't understand. ये हमने share भी किया इसमें chat box
Okay,
में
you can
कि
send me that by email. I'll see what it is.
sir I sent this question in chat box now.
Oh, you have sent it in chat box. Let me see. Here is the chat box.
How come this answer 500 megahertz right answer. My answer is wrong in this question. 250 megahertz.
Okay. For the molecule with a correlation time of 1 nanosecond, the W relaxation path will be dominant at. See, you have to calculate what is the resonating frequency for 1 nanosecond. What is 1 nanosecond? 10 to the power of minus 9, which is nothing but inverse of that you have to take. If you take inverse of that, it is 10 to the power of 9. 10 to the power of 9, I can make it as 1000 into 10 to the power of 6. You understand?
Yes, sir.
10 to the power of 6 is a megahertz. So 1000 is what? 1 gigahertz. The answer is 1 gigahertz.
1 gigahertz. Yes, sir.
With a single quantum is always 1 hour inverse of the tau c. If you take it, it turns out to be 1 gigahertz here.
Okay, sir. Thank you, sir.
But I'm not supposed to give you the answer, you know, because it's an
Yes,
assignment.
sir. My answer is wrong. I
You
250
already submitted,
megahertz.
huh?
Yes, sir.
All right. No problems. See, in the course, I have talked about what is tau c, how to calculate the resonating frequency, everything. If you go in that, 1 second, I will even show you that what it is. Be there, I will open it and show you. This is where you are talking in NOE, right? Correlation time, you are talking with respect to NOE. Am
Yes,
I right?
sir.
See,
Yes, sir.
this is where the correlation time comes. See, rotational correlation time is about the rotation of the molecule. And then there is an expression here which I have given you. Approximately, see, this you have to go by tau c is 0.6 into molecular weight. If you know molecular weight, you can calculate tau c. But you want to convert into frequency. Here it is written for a small protein with a molecular weight of 3.3 kilohertz, tau c is about 2 nanosecond. 2 nanosecond correspond to 500 megahertz. Because 1 over 2 to 10 to the power of minus 9. That is 500 megahertz. But in 1 nanosecond when it is given, it is 1000 megahertz. That is 1 gigahertz. You have to simply take the inverse of that. You know how to take the inverse of that? Tau c is given in nanosecond. If, for example, 1 over 2 into 10 to the power of minus 9, 10 to the power of minus 9 will go to the numerator. It will become 10 to the power of plus 9. So it is 1000 into 10 to the power of 6, you can make it. 1000 when it is divided by 2 will become 500. And 10 to the power of 6 is megahertz. That is why 2 nanosecond correspond to 500 megahertz. You understood?
Understood, sir.
So 1 nanosecond then has to be 1 gigahertz. If it is instead of 2, if it is 4 nanosecond, what will happen? It will be 250 megahertz because 1000 divided by 4 will become 250 into 10 to the power of 6, it is 250 megahertz. Like that, you have to calculate.
Okay, sir. Thank you, sir.
See, if you have any questions like this, you don't have to wait for this. You can always send an email to me or to Sandeep.
Okay,
We'll
sir.
respond to you. You have my number. You can call me. I can explain to you over phone also. You don't have to
Okay, sir.
hesitate to call me. Do you have
Okay,
my
sir. Please
phone?
give me.
Hmm?
Yes, sir.
You have
Please
my
give
phone
me your
number?
number.
Hmm?
Yes, sir.
You have my number?
Yes, sir. I want your mobile number.
Oh, you want it? I thought you already have it. Okay, I'm going to write
No,
it in
sir.
the chat. Hmm?
Okay,
I'm going
sir.
to write it in the chat box. Okay. I have written my number in the chat box.
Thank you, sir.
You can call in that number. Then I will let you know if you are. But don't call at all odd times. Call only in daytime. Okay.
Okay, sir.
Suddenly
Okay.
at night 8:30 during dinner time you get a doubt and don't try to call me.
Okay, sir.
Okay.
Okay. Thank you, sir.
Anybody else? Any other questions?
Sir, just one question. Sir, for different nuclei, we are taking the different samples, like phosphoric acid in the case of phosphorus. So, what are the necessary conditions to as a selection as a reference?
See, one of the important conditions for the reference is the reference molecule should not interact with your molecule. Otherwise, your molecule structure may change. It may become a complex. Chemical shifts will change. Spectrum would be different. You understand?
So, sir, is
One
there
of
any
the
method?
conditions.
Okay.
One of the conditions to choose the reference is the reference molecule should be inert or if preferably not active, do not react with their molecules. Secondly, you should come at a isolated frequency so that easily you can identify. For example, tetramethylsilane is used as a reference for proton, carbon, and silicon. You know why we are using that? Tetramethylsilane has 12 protons, all are chemically equivalent, CH3 groups. It gives only one peak at the very high field region. And then it is inert, it doesn't interact with any of your molecules, highly volatile, it will evaporate very fast so that you can recover your sample. So some of these conditions are there, but you cannot have all the conditions met for all the nuclei. But over a period of time, people with experience, they have identified some of the references for different nuclei. For example,
Yes.
for proton, carbon and silicon, tetramethylsilane is used. For tin, tetramethyl tin is used. For lead, tetramethyl lead. For nitrogen 15, 85%, NH4Cl is used. For phosphorus, 85% H3PO4. Like that, different references have been arrived at over the years.
So, sir, phosphoric acid, also phosphoric acid, H3 4, is not affected the NMR case? Because I never did the phosphor.
H3PO4
Because
used as
this
a
is
reference. H3PO4 is
okay.
used as a 85% H3PO4 is used as a reference. We have only one phosphorus that can be detected. But whether acid, phosphoric acid, whether it interacts with your molecule or not, that is your chemistry. You should decide whether
Yes.
whether it depends upon whether it interacts or not. If it interacts with your phosphoric acid, your molecule interacts, you cannot use that.
Okay.
All right. Do you have any other questions? Anybody else?
Sir, I want to ask, are you taking, sir, the spin dynamics related some course in the next upcoming years also, sir? I just asked for the curiosity, sir.
No, not that. I'm not giving the spin dynamics related course, but the same advanced NMR course covers many things.
Okay.
But now the another
Okay.
course is going on parallelly. That is about spectral interpretation. But in July, I talk
Yes,
about
sir.
basics of NMR. There is one more course. That is for
The
chemists.
July. Okay, sir.
That is
Okay.
in July, not July or August, whatever that session. Next July it will start. Coming July. Look, it is not started, it's going on already since 3-4 years. That will repeat it. You can take that course.
Okay, sir.
Another thing is, every
Yes,
year
sir.
I am conducting the workshop on NPTEL platform, evening workshop for about 1 week, about 10 to 15 hours. I teach NMR for the benefit of the industry people. Sometime during June or July. Last year I gave in July. Before last year, 8-day course I did in June. This year I have not fixed. I have not decided. If I give it time, I will let you know. If be in touch with me, then you can
Yes.
register for that. In a 1 week or 10
Okay.
days, I'll teach for about 18 to 20 hours, all about NMR for the benefit of industry people.
Okay, thank you.
Of course, you can also, everybody can register, but industry
Yes,
people
sir.
prefer in
Okay.
the evenings so that they are free in the evenings. So that course also in the NPTEL Plus platform, I am teaching. You can be in touch with me. I will let you know.
Yes,
This
sir.
is nothing to do with this course. This is a
Okay.
different called NPTEL Plus platform. 1 week workshop I'm conducting every year.
Okay, sir.
Okay, anybody else? Any doubts?
Sir, I have the Neil Jacobson. This book I have it. Actually, that structure I want to show you that this one. The title is.
Show me in the video here. Which is that book?
Yes, sir, I will just write simplified. I have to speak, sir. Simplified theory applications and example for organic chemistry and structural biology. This book I have it. Whatever the you showing.
Who is the author? Tell me the author.
Neil Jacobson.
Oh, Neil Jacobson. It's a fantastic book.
Okay.
Neil Jacobson has two books. One on principles, that understanding of NMR. Other one is on the data interpretation. He has two books. What is the book you
Okay.
are using?
That one is, sir, this is simplified, that type, simplified theory, application,
NMR
and example.
spectroscopy. NMR spectroscopy simplified and explained.
NMR spectroscopy explained, the title is.
Simplified and explained. That one. That's a
Yes,
fantastic
sir,
book.
that is.
It's a very
Okay.
good book, but it talks more about the concept and a little bit of theory. I don't know whether you will follow. If you want a chemistry book, the same Neil Jacobson has a book on NMR data interpretation. It's a very, very
That's
good book.
okay.
It's a very good book. You can use that also.
Okay, sir.
But you send me email, I'll show you, I'll give you the details of all the books which you need to refer and everything.
That is very necessary, sir. So we can go through the details.
Yeah, you write to me, I'll suggest some books. Whatever the books and authors, you can buy it, or some of them you can get a e-copy and everything. Use that.
Okay. Thank you, sir.
Anybody else? Any doubts?
No, sir.
You are cleared. Everything is clear for you.
Okay.
When is the exam of this one?
Okay.
Exam 28, sir.
28th. Your lot of time is there. Okay. Very good. Good luck. I hope you have all understood very well and prepared for the exam very well.
Yes, sir. Thank you, sir.
Very good. Fantastic. All right. Okay. If there are no other questions, I think we can log up.
If there is necessary, sir, we will write mail to you regarding some questions and queries. Whatever some queries related to course, shall I write email to you?
Sure. You can write email to me. And if I am busy, I'll reply not immediately, maybe after 1 or 2 days.
It's okay. Thank you,
You can
sir.
write. So if I think if there are no other people, no other questions, what do we do? Should we log off?
Yes, sir.
So from NPTL, who is there?
Sir, Naveen, sir.
Naveen, okay. So what do? We
We can
log
wind
off?
up, sir.
We can
There
wind
is
up?
no question. Yes, sir.
All right. Okay. So if there are no questions, good luck to both Kuldeep and Sanjita for your exam.
Okay, thank you, sir.
Thank you. So as I told you, you can write to us for any doubt.
Okay.
Now that Sandeep also has joined, you have his email, right? To me or Sandeep, you can write. We will respond to you.
Okay, sir.
And I have given you my number. You call me also if you have any doubts.
Yes.
Okay. All right.
Okay.
Thank you. Okay, Naveen and Sandeep, Wilson,
Sir, how are
we
you?
log off. Sandeep, how are you?
I'm good. So you are must be in abroad, right? Yes.
No, I just came yesterday.
Oh,
I'm back in
so
Bangalore.
very short journey.
Yeah, only very short journey.
So you came ahead of your planned schedule, huh?
Yeah, I came because I have to undergo some cataract surgery this next week. So I did not want to spend time there.
So this week you'll be coming to IAC or?
Not this week, next week.
Next week, okay.
This week I'm busy. Tomorrow also there is this live session. And Friday I'm going to Narada Netralaya for my eye checking. I have to undergo all tests and everything. So I am occupied. Maybe next week I'll come.
Okay.
Okay.
So just for 1 week visit.
10 days, yeah.
10 days. So how was it?
It was very nice.
Yeah, we will talk actually. We will talk personally.
Yeah. We will not in this platform.
Not in this platform.
You will call me. I'll call you later.
Yes, sir. Yes.
All right. Okay.
All right.